The genetically modified organism GMOs debate in Nigeria continues to intensify with a mix of opinions influencing public discourse. While GMOs seem to find rapid applicability in agriculture in Nigeria, concerns over GMOs are valid and deserve attention. It is therefore important to approach the topic from a scientific standpoint and evidence rather than misinformation and fear. Apparently, misinformation about the GMO technology is a problem in Nigeria and can be harmful to society. According to informed sources, this misinformation can prevent people from accessing new crop varieties that could help with food security. With the activism of people who are against the technology, particularly known as anti-GMOs, a greater percentage of Nigerians who display outright ignorance about it, it becomes imperative that urgent explanation by appropriate authorities is needed. Nigerian scientists Dr. Rose Gidado and Dr. Andrew Ilo explain more.
A genetically modified organism, that's GMO, is an organism, be it plant, animal, or microorganism, that a new DNA has been, introduced or incorporated into it, and that DNA is being incorporated for the benefit, of course, of mankind. Let me give an example with a crop that is already commercialized. We have a beans variety in Nigeria now called the pod borer resistant cowpea that has a gene in it, cry1AB protein, and actually that bean is meant to give protection to the beans against the destructive activity of a maruca insect larva. Maruca is a butterfly, and when the butterfly is at the developmental stage of the larva aspect, the one that crawls, around the beans plant, it eats up the flower, it eats up the leaves, and it's also burrows into the pod. When the pods are formed, it goes into it and then destroys the seeds that are being formed inside. And it can actually cause almost 90% loss to the farmer. So it's highly destructive. Beans is actually susceptible to many more other insects, like the stainers. There are many, but the maruca causes the most, damaging effects on the beans, leading to 90%. So some farmers, they lose, especially in the maruca endemic areas. The farmer can end up not having anything that year, and that is his only source of livelihood. Of course, he has no any other means, to make money or get maybe food to eat. So I think this is what the farmers actually had been going through. This does not only happen to beans, but we have other crops like the maize. We have the fall armyworm. So there are different types of insects, really. We have the cotton, which is pink bollworm. They all cause a lot of damage to these crops, destroy them. And the conventional technology can actually not give solution to this. If you are using a seed that is not improved genetically, you have to do a lot of sprays, up to 10 sprays. The farmer has to do 10 to 12 sprays in case of cotton before he realizes any, good yield. And that farming is about having strong yields, harvestable yield, enough so that he can take the farmer around. The farmer can sell part of what he has produced and then the remaining part he can eat as food. And the money he makes, of course, it should be enough to pay his children's school fees. But just spraying that liquid spray that they do, sometimes some of these chemicals are fake. Most of them, you find out that they are not effective at all. And once you spray and it rains immediately, it washes it off, and that is it. So it doesn't really work all the time. So most times they end up with yield, either like in the case of the beans, the yield the farmer gets from the locally produced beans is 350 kg. So where can that take the farmer to? And in case of cotton, it's now 150 kg to 1 ton. So but with these new varieties, that
the GM varieties.
the GM varieties that have been genetically modified and have had a new DNA in it, and that DNA of course contains that gene, CRY1AB gene, that protects that crop from being attacked by some of these insects. So it has the yield of this, like for the beans, the yield is 2.9 tons. That's the highest like you can get on a well-managed farm. Then for cotton, you can have a yield of 4.1 to potential yield of 4.1 to 4.4 tons per hectare if the farmer manages it very well. And for tailor maize, you can have yield between 7 to 10 tons, like in between, if you manage it so well. It depends on your management practice. Yeah, even though it is modified, it is actually, the modification is to take away that challenge. It's actually not for it, maybe for you to have it, but to take away that challenge. We believe that when that challenge that prevents the farmer from having high yield is taken away, of course the yield comes in, because one, the number of sprays that maybe the farmer used to do, 10 sprays, can now go down to 2 sprays, so that he can realize that yield. Because already the farmer is not going to experience that damage by some of these insects. That protection has been given to the crops against those insects. So the number of sprays go down. So you're only going to do maybe 2 sprays. And those 2 sprays that you're going to do are going to go just against the non-target insects. That's those insects that the crop was not developed to, the protection is not against them. The protection is actually just against one insect. But others can still come and be doing destruction, even though their destruction is not as much as the ones that's the target insects. So at least that's what a GMO is. Any either plant, animal that has had its DNA altered, but altered for specific reasons, for benefits, so that whatever you're doing it, whatever trait you're introducing, the trait is not only for insect, it can be for drought tolerance, it can be, depends on what the challenge is. It's just to take care of the challenge, because most living things were controlled by the genes. And this technology actually started after the discovery of DNA. The DNA structure is same in all living things, both plants, animals, and even the micro organisms. It's only virus that has RNA instead of DNA. So it's the same structure in all the living things. So it doesn't matter where you are getting your gene from, because it's the same thing. You are taking it from another living organism and taking it to another living organism, because you believe that what the trait that you want, what you're looking for, maybe another living is there in another living organism. It's actually genes that you are taking, the genes that will code for that trait that you want.
For us who are scientists in the field, we've had our own scientific evidence to show that these genetic modification, by the way, genetic modification we're talking about is, for example, insect resistance in cowpea, that's beans, or insect resistance in maize, or in cotton. These are the 3 approved kind of genetic modifying crops we have in Nigeria. Others are still in research. For example, the cassava one is still in research; it's not yet out. The soil beans too in Nigeria is not yet out, but in America it's out. So for Nigeria, I'm going to categorically be talking that about the beans, or cowpea as it's called, cotton and maize, which is on ground, are considered safe because they pass through quite a lot of safety assessments. As a scientist, it's our job to do the science. It's another people's job to look at that what we are doing meets the human consumption. I give an example. Cowpea didn't just come into existence. It took over 20 years of research before cowpea, the PBR cowpea, could be brought out for commercial release. And those 20 years were not just 20 years of dancing disco. It was 20 years of serious genetic work. Because even in my own laboratory, we have planted beans. In fact, we just harvested in this last planting season. We just harvested cowpea, GM cowpea, alongside normal cowpea. And before we did that, we tested the soil to look at the soil microbial content, soil nutritional content. After we harvested, we are also have undergone soil nutritional tests, because the controversy is that when you plant, you cannot plant again there. We've tested, and the soil nutritional component nothing happened. In fact, as a matter of fact, there were more pesticide residues on the non-GM cowpea, because that is the one we sprayed more pesticides on. So there were more residues of pesticides on. After we did the HPLC analysis of the soil, we found out there were more pesticide residues on the beans, on the soil, that where we planted the non-GM when compared to the GM, because we had less pesticide application on the GM. Now, even in terms of yield, we even saw that we had even more yield on the GM than the non-GM. So these are some examples of empirical evidence when you're saying that to debunk some of the controversies around GM.